Hello guys, so in this video I will highlight or give overview about the latest assignment, homework 18. Okay, it's about one of the very famous multi-stage amplifiers. It's called Cascode amplifier. Yeah, I know the name is a little bit weird, but this is how they call it. So this Cascode amplifier is actually two stages again. In the lectures we take a common emitter with a common emitter, two stages, both are common emitter. We also studied common emitter with a common collector, and this one in the assignment is common emitter with a common base. Okay, this circuit has a very good frequency response, something that we didn't touch in our course because it's advanced topic, but it has advantages that we will not touch in our analysis now, but it's advanced topic. Anyways, so in this video I will show you how to implement, or I'm sorry, how to construct the AC equivalent circuit. I will explain how this is actually two stages, because when you look at the circuit, you will have some doubt about that. So I will show you that it's really two stages, and really the output of the first stage is actually the same as the input of the second stage. And also I will highlight how to solve the DC, how to make the DC analysis of it, how to get IE, IC, and RBI, of course, and of course to use that in our AC afterwards. So let's go here to the circuit. The circuit looks a little bit complicated, but we will try to go into the depths of that circuit to show where is the inputs and where is the output, and convince you that it's really two stages, and one stage is actually delivering to another stage, to the second stage. Good. So I said that we have two stages, common emitter and the common base. So common emitter, before we go and analyze, so in the common emitter, the input is at the base, the output is at the collector. The common base, the input is at the emitter, and the output is again at the collector. Good. So let's see here what transistor is which. I mean, which one is served as a common emitter and which transistor is served as a common base. So let's start by the bottom one, okay? Because it's near the input. So the input here is going into the base. So let's call this Q1. Let's call this Q2. So the input of the whole circuit is at the base of Q1, base 1. Now we need to know where is the output of that transistor. It's either the emitter or the collector. We don't have a third option, because the third option is the base and it has the input already. Okay, just look at it. In EC, this capacitor will be short. So it will short RE. So the emitter will be connected to ground, 0 all the time. So definitely the output is at the collector. So the output, let's call it VO1, is at collector 1. So you have here a transistor with an input near the base and the output at the collector. So Q1 is our common emitter amplifier. So common emitter is at base 1 and the output at collector 1. Good. Of course, the second one should be common base, but I will prove that with you now. Okay. So again in EC, this capacitor will be short. So the base of Q2 will be 0 all the time. Right? So definitely there is no either input or output at the base of Q2, base 2. So the only option now is that the input at the emitter and the output at the collector, which is the common base, right? But let's see where is the input exactly. So here is emitter 2. And the emitter 2 is actually same as collector 1. They are the same point. So actually, the output of stage 1, which is the common emitter, is actually the input of the common base, because the collector 1 is actually the same as actually the emitter 2. Same note. Okay? And definitely now here is RL. So I am writing here that this is the output. So the output is at collector 2, which is expected from a common base amplifier. Okay? This is in DC, you know, I didn't draw the AC equivalent. When I draw the AC equivalent circuit, you will definitely be sure that and convinced that yes, that the output of the of stage 1 is actually the input of stage 2. You will be you know, very satisfied when I show you that also on the EC equivalent circuit. But before that, let's see now, examine how to solve or how to solve this circuit in DC. Okay, how to get the Q point. So the EC, so some instruction with the DC analysis. So number 1, the DC analysis. I will not solve it, you know, I will just write equations for you, you know, the assumptions that we use for such a circuit to solve it. So usually we neglect I base 1 and I base 2. We usually do so. Okay, this is, you know, and by the way, you can solve it without neglecting them, but to make it easy for you, you should neglect them. Okay. Good. Also, to solve it easily, there is, you know, some you know, equalities that is hold, and it will make your life very easy when you solve. So, first of all, as I said, collector 1 is actually emitter 2, right? Same point. So IC or IC1, I'm sorry, is actually IE2. So basically, and we usually use, you know, beta very high. So IC1 approximately equal to IE1, and IC2 approximately equal to IE2. So based on that, IC1 equal to IC2 equal to IE1 equal to IE2. So definitely I base 1 equal to I base 2. And of course, here the transistors are identical. They have the same beta. That's why we were so confident, you know, we make that assumption that I base 1 equal to I base 2, you know, and we are sure about it because beta is the same for both transistors. Okay. If you neglect I base 1 and I base 2, you can consider that R1, R2, and R3 just in series. So by neglecting I base 1 and I base 2, R1, R2, R3 can be considered as series resistors. I mean, if we consider here a current equal to I1, a current equal to I2, a current equal to I3, so you can say that I1 approximately equal to I2, approximately equal to I3. So based on that, if they are really, you know, in series, then the voltage at the base one, VB1, which is the voltage of R3, I'm sorry again, which is the voltage of that node. So VB1 number 4, VB1 is equal to VCC multiplied by R3 over R1 plus R2 plus R3. Not just that. V base 2 here is also, you can do the same with V base 2. So V base 2 equal to again VCC, but now it's R2 plus R3. So R2 plus R3 over R1 plus R2 plus R3. Okay, we want to determine IE now. So here is V base 1. You know that the voltage here is 0.7. So number 6. VE1, the voltage here, VE1, is equal to V base 1 minus 0.7. And since you determine VE1, simply IE1, which is IE2, which is IC1, which is IC2, equal to VE1 over RE. If you want to determine VC1 and VC2 to check that you are really in the active region, that's also easy. So number 8 here. VC2 first because it's easier. VC2 is equal to, this is VC2, equal to VCC minus IC2RC. So VCC minus IC2, which is equal to IE2, or IE1, I'm sorry, RC. VC1 is equal to, remember again, here is also there is 0.7. And the VC1 is actually VE1, same point, same node. So VC1 is equal to V base 2 minus 0.7. So number 9, VC1 equal to V base 2 minus 0.7. And of course, to check that they are in the active region, V base 1 should minus VC should be less than 0.4, and V base 1 minus VC1 should also be less than 0.4. Okay, good. Now the AC analysis. So let's put a line like this. Number 2, the AC analysis. I will not do the AC, but I will just draw the equivalent circuit for you. But in the assignment, you have to derive expressions for some of the characteristics like our input, our output, AV and GV and stuff. Okay, and of course you calculate, you just apply some numbers and you get these results. Okay, so let's start by adding. I will just copy and paste the circuit again. Okay, to make it easy with that's much better than going up and down each time. So, okay, so let's first short the capacitors. So this will be short, this will be short, this will be short, this will be short. Cancel DC sources. So this guy, it's just one source. So this guy will be short. So before we continue, here is a short 0, and here is another 0, so you can connect them to each other. So R1 will be cancelled. It's shorted. So R1 will be shorted. RE is the same also because this is now 0 and this is also 0, so it's also shorted. You can just make like this, it's also shorted. Okay, good. We will put the equivalent circuit, we usually use, we have two models for the transistor. Both are equivalent, okay? But there is one is that we use with common emitter and common collector amplifiers, and another one which we use usually with common base. So we will combine them now. So we have two transistors, so you have two transistor models. So the first one is a common emitter. Beta IB, IB1. Here is R by. You have R by 1 and R by 2, but since I base 1 equal to I base 2, R by 1 is equal to R by 2. Okay. So I will just call them R by. Emitter 1, base 1, collector 1. And I base 1 is flowing in that resistance. The equivalent circuit of the second transistor, let's draw it in green, will be the one for the common base. So for the common base, we put the emitter, the base like near the ground here. Oh, this is too close to the. Base 2, alpha IE. Here is RE, but RE is equal to R by over beta plus 1. And when beta is very big, you can say it's R by over beta. Why I did this? Because it will make your life easier when you do the analysis. Okay, believe me. So make it, leave it with as R by equal beta. So I will remove RE and put R by over beta, which is exactly the same, no problem. R by over beta, or beta plus 1, but it's very big, so you can just make it beta. Here is alpha IE2, and IE, remember, is flowing from the base to the emitter, so this is the emitter 2, and here is collector 2. Let's now draw the rest of the circuit. So let's start by base 1. So let's make it with another color. Here is base 1. So base 1 is connected to 3 branches. 1 branch, 2 branch, and 3rd branch. So these two resistance R2 and R3 are actually parallel because they are connected to the same start, or one terminal, and also the second terminal is the same because the second terminal here is the ground, and also here is the ground. So between base 1 and the ground, you have R2 parallel R3. And you have then R signal and V signal. This is V signal, and here is R signal. We finished with base 1. Now emitter 1. So emitter 1 here is just connected to ground, so that's very good. I mean, usually when the emitter is connected to ground, it makes your life easier. Now collector 1 are actually connected to emitter 2. So just connect them like this. That's it. Very, very easy. Base 2 is connected to ground. Very nice. And now collector 2, you have 2 branches, one with RL to ground and one with RC to ground. So RL, RC. Now, where is V input 1, V output 1, V input 2, V output 2, and the main input of the circuit and the main output of the circuit? Stage 1. The input is at the base. Here is the input. So V input 1, which is actually also the input of the whole circuit. So the input 1 is equal to the main input to the circuit. Where is the output 1? It's on the collector. Remember, this is a common emitter. Here is the collector. So here is between this point and the ground. Here is the output 1. Where is the input 2? The input 2 is between the emitter 2 and the ground. Here is emitter 2, here is the ground, so it's actually the same point. This is the input 2. So looks like the input 2 is actually the output 1. Where is the output? The output is between collector 2 and the ground. Here is the output 2. And it looks like this actually the whole output of the circuit. So it's clear now that you have two stages, and the output of the first stage, this is the first stage. Let me draw it for you with another color. The output of the first stage is connected to the input of the second stage. So this is stage 1, common emitter. This is stage 2, stage 2, common base. And the output of the common emitter is the input of the common base. That's really beautiful. Okay. Now your life will be very easy now. You will just need to solve the circuit to find AV1. So AV1 is basically the output 1 over the input 1. AV2 is actually VO2 over the input 2. AV, you know, the total is just VO over VN, which is VO2 over the input 1, okay? JV is equal to AV Rn over Rn plus R signal. Where is Rn, by the way? So Rn is between the same terminal of the input. Where is RO? Between same terminal of the output. Okay, guys. So this is the highlight of. I should actually. This is a solution for it. So you just need, you know, to practice it yourself to find these parameters and solve the DC and get numbers, of course, and, you know, solve the quiz. So thank you very much for watching this, and, you know, good luck. Bye-bye.